Hello students, greetings of the day. So today we'll talk about a wood machine. So how it works and its principle, let us see. So a wood machine or a pulley block system. Okay. Now we have a pulley here. Purpose of pulley is what? It is used to change the direction of force acting on it. We'll understand better way. Like for example, we are having a well. So where we want to lift the water from it. So in olden days you used to see like this, we are having what, a kind of pulley kind of arrangement. So by bucket arrangement, and from this particular floor, for example, you are pulling the bucket, so you're pulling it. So when you're pulling here, the tension force acts from this one like this, and the bucket will come up, isn't it? So this kind of arrangement was there. But if this bucket was what you can call this pulley arrangement was not there, so how you used to lift the water? So this is a water, for example. So you are standing here, so by means of, if you lower a bucket of water here, so you have to pull it. So you have to apply the force upward direction, and you have to lift it against gravity. Yes or no? But when pulley arrangement is over here, so what you can do here, this kind of water kind of thing, when you immerse the bucket, so when you are, see here, you are applying and you are pulling it down, right, by applying force. So you are applying force in the direction of gravity, and that force is being applied over here, and the what, bucket is being lifted. So in this case, you can see first case here you are applying force upward, isn't it, against gravity you are applying. It's a very difficult task for lifting the object. But when you make pulley arrangement here, in the direction of gravity you are pulling it, and your task becomes easy. So like this, pulley is useful for changing what, direction of force which you are applying on the objects. So this kind of machine is called what, wood machine. Now here pulley arrangement you can see here. So generally we take here massless pulley and frictionless pulley, we can say, and a block of mass M is suspended here, and you can pull this side, or you can connect another block of mass M here. Now this mass is, for example, say capital M. Based on the value of, if capital M is more than small m, so this side force will be more, this side force will be less. So if you draw the FBD of this pulley over here, what will you get now? So if you draw the FBD of the pulley, the force is acting here on this tension T like this, here also tension T like this. If you suspend over here, no, tension T dash, for example, say it is here. Now if you draw the blocks, FBD is now here, this is capital M, its own weight will, capital Mg will act here, tension will be T. If you draw the FBD of over here, small m, so what happened, the force acts starting on it, this is Mg, this is what, T. Now our concern here is, so when the system is released from rest, what will be acceleration of the system and tension in the string, we will talk here. So now if you see in this question, if you mark this particular forces on it, so here tension for this pulley is in this way, right? So for the pulley, tension is like this, and for the block, tension will be here in this way. Now if you mark the forces here, this is Mg and this is tension T. So the string is same, throughout the string tension remains same, isn't it? So now here its weight Mg is acting downward, tension T. Now write the equation for this as you have drawn the FBDs. If you read the system, if you assume M is more than M, this will try to go downward, this will try to go here upward. Yes or no? Now as you have drawn already FBD, they mark the direction of motion. So if it is going downward, acceleration over here downward. If it is going upward, acceleration is here upward. Now write the Newton's second law equation. What is that formula? F net is equal to mass into acceleration. So here, so if I apply this force for this capital M mass, so what you can write here, Mg minus T, going downward, right, M into A, one equation you will get. And for smaller block, you can write the equation, what will you get? So for this, tension is upward, right, so and acceleration is upward, so you can write here, so tension so tension T upward minus weight Mg downward, which is going up, no, so M into A, you can write down. So you can solve these two equations. 1 plus 2 if you do, you'll get the value of what, acceleration. So when you add these two equations, this plus T minus T get cancelled. So we have Mg minus small mg is small m plus capital M into A. So what will be acceleration beta here, which is equal to Mg minus Mg divided by capital M plus small m. Or you can take here, so capital M minus small m, G common you can take, divided by capital M plus small m. It's very simple way you can understand this one like this. As the pulley system is suspended here, right, This is M, this is capital M. Fine. Now here you are saying mg acting downward. Here we are saying mg acting downward. See, this tension becomes internal force, right? As a together pulley plus block system together, if you take as a system, only external force acting is what? Mg and mg. And this mg is trying to pull from this side, this mg is trying to pull this side. So if capital M is more than small m, definitely what happens? This system will move this side. So net force in the direction how much? Mg minus mg. This must be equal to mass into acceleration. Okay. So from here also you can get simply m minus m into g by total mass of the system here. So m plus m. Okay. Into a. This becomes m plus m. So net force is equal to total mass of system into acceleration. That's what we'll get the same answer here. Okay. Or else you can think of this one like this also. As this string is connected like this, right? These two forces are, one is left and the right. So assume that, so this is capital M and this is small m. This side rightward force mg, this side force capital mg. So if this is more, it will go this accelerate leftward. Okay. So now you can write the equation now. So net force on this system, how much now? This is capital mg. Okay. So capital mg minus small mg is equal to total mass of the system is capital M plus small m into acceleration. So what is the acceleration of system now? M minus m into g by m plus m. Okay. And similarly, so this is how we have done. So net force is equal to mass into acceleration. Or how to find the value of tension here? How to find the value of tension? So same thing you can say here. Now in this case, see, for this tension like this, for this tension like this, so tension T, entire string is same, tension remain the same. You can take FBD of any one block. So if you take capital M, so for this tension acting like this side mg like this, acceleration is in this way, right? So you can write down here now, so mg minus T is equal to m into a. So T will be how much now? mg minus me. Solve for T. How much will you get? mg minus capital M into a value how much? Capital M minus small m into g by m plus m. If you simplify, how much will you get? Yeah. So multiply here. M you can take common. So you can write this is g into m plus m. G into m plus m. Okay. So minus m minus m into g divided by m plus m. Okay. So capital M into, you can do simplification, mg, capital mg minus multiply minus mg plus small m into g. So divided by how much beta? M plus m. So you can cancel these two. So we'll have 2mg into m. So 2 capital M small m into g. Okay, 2 small m capital M into g by m plus m. This is tension. Okay, if you take m1 m2, 2 m1 m2 into g by m1 plus m2. So this is how we'll take tension. Okay, and what? Acceleration. So net pulling force, simply you can write here net pulling force by total mass of the system. Okay, acceleration means, and tension is equal to 2 m1 m2 by m1 into, or you can simply m1 m2 if you consider, no, 2 m1 into m2 into g by m1 plus m2. So we have taken m1 greater than m2 we have taken here. Okay, if m2 is more, acceleration will be how much? m2 minus m1 into g by m1 plus m2. Okay, so like this we have, so simple pulley system, and purpose of pulley is to change direction of force. Just mark the blocks, forces on it, consider net force equation, mass into acceleration. Okay, so fine, thank you. So please do subscribe and stay tuned for my channel. Thank you all.